Let's take a look at Chapter 2. Section 2.1 is a rectangular coordinate system and graphing utilities. And first topic is plot points on a rectangular coordinate system. If we're wanting to graph or plot 3, 1. When you're given a point, also called an ordered pair, the first part of the point is your x and the second part is your y. So if we go to x is equal to 3 and y is equal to 1, where the point goes is the intersection. If I were to draw lines, vertical line at 3 and a horizontal line at 1, where they intersect is where our point goes. This is a similar topic as if you remember the game Battleship, where you had like A3 and you go to the intersection of A and 3. Exact same idea. Now using the distance and midpoint formulas. Now given 2 points, x sub 1, y sub 1, and x sub 2 and y sub 2, we have our distance formula, which says the distance between those 2 points is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. We also have our midpoint formula that says the midpoint, the point halfway in between those points, is given by the point, the ordered pair, x sub 1 plus x sub 2 divided by 2, so you add together your x parts, comma, y sub 1 plus y sub 2 divided by 2. So let's say we had a point negative 3, negative 1, and negative 4 and negative 9. And we're going to not only find the distance between them, we're going to find the midpoint between them. Well, first thing I'll do is I'll label these. This is my first point, so I'll label this as x1, y1. This is my second point, so I'll label this as x2, y2. Now, it does not matter which one you label as your first point, which one you label as your second point. It works out either way. It's always best when you're doing a distance formula if you go through and replace all of the variables with parentheses before you plug in your numbers. So I'll make these a little bit bigger, the outer ones. So I'm just going through, and everywhere I have a variable, I put in a small set of parentheses. Well, y2 we said was negative 9, and y1 is negative 1. x2 is negative 4, and x1 is negative 3. So then we have negative 9 and minus a negative 1. A negative becomes positive. So negative 9 plus 1 squared plus negative 4, negative gives us positive. So negative 4 plus 3 squared. Negative 9 plus 1 is negative 8. So we've got negative 8 squared plus negative 4 plus 3 is negative 1. So we've got negative 1 squared. And that's going to give us 64 plus 1, which is the square root of 65. Now you always try to simplify your radicals at that point. I don't know if this simplifies. Let's see. 1, 5 times 13. No, it doesn't. Now our midpoint. Midpoint's a lot easier. You don't have to put the extra parentheses in. All you do is add together your x parts, which are negative 3 and negative 4, and divide by 2. And you add together your y parts, which is negative 1, negative 9, divided by 2. And that gives us negative 7 halves. Negative 1, negative 9 is negative 10 halves, which then simplifies to negative 7 halves and negative 5. And that would be our midpoint. Let's see. graph equations by plotting points. Let's talk about that. We got y is equal to, say, 3x minus 1. Now we're going to build something called a t-chart. The reason why it's called a t-chart is because these lines here look like a t. And we want to pick x values to plug in. Now it doesn't matter which one you pick. So I'm going to pick 0, 1, and 2. You want to keep them fairly small. You don't want to choose like 1 million or 1,573,000,000. Keep them small. And then we're going to plug that in. We'll plug in x equals 0 into our equation. So we're going to have y is equal to 3 times 0 minus 1. 3 times 0 is 0, so that gives us negative 1. Now that means we're going to have the point 0, negative 1, which is right there. And then we'll plug in our next x value, which is 1. So I'm going to have y is equal to 3 times 1 minus 1. 3 minus 1 gives us 2. So we're going to have point 1, 2, which is right there. And then we'll plug in our next x value, which is 2. So we're going to have y is equal to 3 times 2 minus 1, which is 6 minus 1, or 5. So we got 2, 5, which should be right there. Now after you get those, then you draw a line through them. Make it a little bit bigger if you miss it slightly. And that would be our line. Now part of the problem of plotting points is you have to know what your graph looks like before you begin. This is linear. Everything was the first power. So I knew that I needed 3 points. 2 points is all you need for a line, but that third point is a check on your basic math. On the other hand, if you got y is equal to x squared, not knowing what it is, you may not pick enough points for your t-chart. But that's on graphing equations by plotting points. Now identifying your x and y intercepts. Now it says identify. It doesn't say find the x and y intercepts. But down here it does. Determine the x and y intercepts of a function. So that's a little bit differently. This just refers to looking at a graph and seeing what your intercepts are. And I'm just going to write down definition for that. I'm not going to actually find it now. Later on I will. For your x-intercept, this is where your graph crosses or touches the x-axis. And for your y-intercept, this is where your graph crosses or touches the y-axis. Actually, I could probably make up an example there. Okay, so if we have this graph here, and assuming those tick marks each represent just a unit of 1, I see it crosses my x-axis in 2 places. Crosses at 1 and 3. So you can write 1, 3. If you want them in point form, that would be 1, 0 and 3, 0. Now our y-intercept looks like crosses the y-axis at 3. So you could write 3, or if you want to write it in point form, that'd be 0, 3. And that'd be identifying your x and y intercepts. Now graph equations using a graphing utility. And I'll put a YouTube video out on this, so I won't spend a whole lot of time on it, but let me just show the very basic one. Or cover some of the very basics, I guess. Let me erase this, since I'm down at the bottom. Okay, y is equal to x, y is equal to x squared, y is equal to x to the third. Those are probably good ones to start with. Now y is equal to x. I press my y equals, my calculator, TA3, TA4, and I do my clear. Now this is specifically using a graphing utility, not by hand, not by plotting points. So y equals clear, and then I'll do my x key, and then I'll do a graph. Okay, so press my y equals, and you'll see it in red where the button's at. Clear clears out wherever's on the line. Then I push my x key. This says xt theta little n, doesn't say x key. That's too hard for me to write each time, so I always just write x key. And then graph. And that gives us our graph. Now y is equal to x squared. We do y equals clear. We'll do x key, push the x squared button, and then graph. Okay, so press my y equals clear. I do my x key, and here's your x squared. Now the x squared just puts a squared on there. It doesn't actually put the x on there for you. And then graph. Now how we do an exponent? We got y equals clear. We'll do our x key. And how we get the exponent is we do the caret. And then 3. And then graph. And that would look like that more or less. So if I press my y equals, press my clear, I do my x key, caret, 3, and then graph. Now there's a lot of other graphs that's in the video, so I definitely recommend watching the video, and you'll see a lot more, get a lot more information on the TA3, TA4. In the interest of time, I'm not going to show every one of them here. Now section 2.2 is circles. Pretty much this whole chapter is involving looking at a lot of different graphs, finding some different functions, talking about what a function is. Okay, so circles. Now our first topic is writing an equation of a circle in standard form. So let's talk about what standard form is. Let me clear that off. Now standard form is when you have x minus h squared plus y minus k squared is equal to r squared. Now if you have it in that form, then your center is hk, and your radius is r. Now this first topic here says write an equation of the circle in standard form. So we're wanting to write it in standard form. So probably you're going to be given some information. Maybe they tell you your center is -2, -3. And they tell you your radius is 5. And then the instructions say write the equation in standard form. Well, we have to identify everything they give us. They've given us a center, so they've given us h and k. So telling us h is -2. And they're telling us k is -3. And r is equal to 5. So then we plug these values into our standard form. So we're going to have x minus h, so I have x minus a -2 squared plus y minus k, and k was -3 squared, is equal to r, which is 5, squared. And we do a little bit of simplifying. A negative negative becomes positive, so we've got x plus 2 squared plus y plus 3 squared is equal to 25. And that would be our standard form. Now the next topic is to write the general form of an equation of a circle. So general form of an equation of a circle. Well, let's say we're given a circle. They tell us the center is 2, 1, and our radius is 4. If I were to graph it, center's 2, 1, it'll be right there. Radius of 4 means I've got a distance of 4 in any direction. This is the outer edge of my circle. Okay, so we want to write the general form of the equation of the circle. Well, if they give us the center, they're giving us h and k. So here they're telling us h is 2, and here they're telling us k is 1, and obviously this is r, that's our radius. Now our standard form says we got x minus h squared plus y minus k squared is equal to r squared. So we'll plug in the values they give us. X minus h, which is 2, squared, plus y minus k, which is 1 squared, equals r squared, which is 4 squared. Now x minus 2 squared is x minus 2 times x minus 2. Y minus 1 squared is y minus 1 times y minus 1, equals 16 squared, or 4 squared, which is 16. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. That's FOILing. Y times y is y squared. Y times negative 1 is negative 1y. Negative 1 times y is negative 1y. Negative 1 times negative 1 is a positive 1. And I'll bring the 16 over. So we got x squared. Negative 2x is negative 4x. 4, actually I'll combine numbers here in a minute. Y squared, negative 1y is negative 2y. 4 plus 1 is 5, minus 16 is negative 11, equals 0. Now standard form is this format right here, but general form requires these squared parts to be together. So we got x squared plus y squared, then the x and y, so negative 4x minus 2y, and minus 11 equals 0. And that's our general form. Occasionally some books will put the constant term, the negative 11, over on the right side. That's our definition of general form. Okay, right, general form. Okay, and then functions and relations. Determine whether a relation is a function. Let me clear this off. Now a function says for every x there is only one y. Now this works fairly well if you're talking about working with points. For example, if I'm given the point 1, 2, 2, 3, and 3, 7, what we do is we write down our x values, going from smallest to largest, not repeating any. So I got 1, 2, 3. And we'll write down our y values, going from smallest to largest, not repeating any. So I got 2, 3, 7. Now this point here, 1, 2, maps 1 to 2, so I draw a line between them. This point here, 2, 3, maps 2 to 3, so I draw a line between them. And this one maps 3 to 7, so I draw a line between them. Now for that definition to be true, for every x there's only one y, you can only have one line coming out of each x value, which is true. So this is a function. Now on the other hand, if I had 2, 3, 6, 5, 2, 4, and again I write down my x values and my y values, going smallest to largest, not repeating any. I got 2, 6, 2, so I have 2 and 6. For my y values, I got 3, 5, 4, so I got 3, 4, 5. Now this point maps 2 to 3, so I draw a line between them. This one maps 6 to 5, so I draw a line between them. And this one maps 2 to 4, so I draw a line between them. Now for every x, there's only one y. But notice here we have 2 lines coming out of this at one x value. So it's going to 2 different y values. So this is not a function. Now that's a hard definition to work with. So we got an easier definition. And it says if you have one of the following, it is not a function. So if you got an x to an even power, it's not a function. If you got the absolute value of y, x to an even power, let's try that again. If you have y to an even power, it's not a function. If you got the absolute value of y, it's not a function. If you got the plus or minus symbol, it's not a function. Let me go ahead and put that as the exponent. There we go. If you got x is equal to a number, like x is equal to 3, it's not a function. Now this is a better one to work with in this class, because we'll be dealing with more than just simple points. If I had y is equal to x squared minus 2, for example, and the question is whether it's a function or not. Now these are the items we cannot have. If you have any of these, it's not a function. Y to an even power, we don't have that. We have y to a first power, which is fine. Now we have x to an even power, but that's okay. We just said we can't have y to an even power. And I don't have anything else. You might say, well, that's an x minus a number, or x plus a number. This is saying x is equal to a number means that that's all you have, like x is equal to 3 or x is equal to 5. Or you could have even x plus 7 is equal to 0, because then you could take the 7 over. Since this does not have any of the bad items, this is a function. Now if I had this, x squared plus y squared is equal to 9. This is actually a circle we talked about earlier. Notice it has y to an even power. Since it has y to an even power, this is not a function. Okay, let me clear that off. Now we're talking about function notation. So function notation. It has two purposes. One is to give a name. For example, if I had y is equal to 3x minus 1, and I had y is equal to 5x plus 2. And if I asked you to graph these, if I asked you to graph y, you'd say, well, which one? So instead of calling them y, I give it a name. It's not like Bill or Bob or Sam. I call this one this. Now that's read as f of x. Or we even get lazier in mathematics and just call it f. This one, maybe I'll give this name too. Now how you read that is that's g of x. Or we simply say g. Now there's no mathematical meaning there. That does not mean f times x or g times x. It's purely notation, purely given a name. That's got a second purpose, to reduce writing. And this is best shown by example. We had problems before that said evaluate y is equal to 3x minus 1 for y when x is equal to 5. That was easy enough. What we did is we went through and we put 5 in where there's an x. So we get y is equal to 3 times 5 minus 1, y is equal to 15 minus 1, or y is equal to 14. Now instead of writing all those words, we could simply say f of x is equal to 3x minus 1 and say find f of 5. Then it's found the same way. You go back to the original problem, and everywhere you have an x, you put in parentheses, and you plug in whatever number you're evaluating for, which is 5. So it's 15 minus 1, or it's equal to 14. So those are the two purposes for function notation. Now specifically on this topic, they're saying to apply the function notation. What they're implying there is that I believe is to evaluate a function. So let's look at a little harder problem than what I did. Let's say we got f of x is equal to x squared minus 7x plus 1, and we want to find f of 2. So we're evaluating. Your first step is you go through, and everywhere you have an x, you put in parentheses. So we got parentheses squared minus 7 times parentheses plus 1. Everything else remains exactly the same. Now whatever's inside of parentheses right here is automatically what you put in here and here. That's what you're evaluating for. So 2 squared is 4, minus 7 times 2 is 14, plus 1, which gives us negative 9. And that's our answer. Now determine the domain and range of a function. I'm guessing what they're asking for here is to do it graphically. Range is kind of hard to find algebraically. So let's talk about that. We'll have a function here. And the question is what the domain and range is. Well, first off, let's talk about what the domain and range are equal to. Now I'm just going to write this in terms of x's and y's, but your domain is your x values where your graph exists. And your range is your y values where the graph exists. Okay, so for our domain, if I come over here, domain you can think of up and down. If I come over here, negative 2. If I go up or down, the question becomes, can I find my graph? Well, if I go up or down, I don't find my graph anywhere, so it doesn't exist there. If I come out here to x equals 1, if I go up or down, I don't find my graph anywhere there. It doesn't exist. It actually doesn't start existing to right here, 2. And then it goes forever in this direction, which means it's going to positive infinity. Now, since there's a solid dot here, we're going to put a bracket on 2. You always put a bracket unless you got an open dot. And then infinities always have parentheses. Now our range. If I come down here to like negative 3, range, you look left and right and see if you can find your graph. My graph doesn't exist down there. It actually doesn't start existing to right here. If I come straight over to my y-axis, that's 0. And then as this is going to the right, it's slowly going up, so it'll keep slowly going up forever, which means this is going to positive infinity. And again, unless you have an open dot, it's always bracket, and infinities always have parentheses. So that'd be our domain and our range. So one more of those. Our domain and range again. Now, as this is going down here, it's slowly going to the left, and it'll keep slowly going to the left forever, which implies it's going negative infinity. Now, as this is going to the right, or as this is going down, it's slowly going right. It'll keep slowly going right forever, which implies it's going to positive infinity. So our domain is negative infinity to positive infinity. Now our range. It's going down forever, which means it's negative infinity. The highest point of my graph is right here, and in terms of my y-axis, that's y is equal to negative 2. And I'll put a bracket on that because the only time you put a parentheses on a number is when you got an open dot, open circle. And I don't have that there. Okay, that's section 2.3. Now 2.4 is linear equations in two variables and linear functions. And number 1 says graph linear equations in two variables. And there's different ways we can do that. Yeah, I guess that's we'll take a look at that. We already looked at plotting points, so I'm not gonna show that again. But there is another method for graphing a line. I got 2x plus 4y is equal to 8. We can graph using the intercept method. Now let me put some steps here. Graphing a linear function by points, by plotting points. Step 1, build a t-chart picking 3 different x values and plugging them into the function to find the y values. Step 2, plot the points. And step 3, draw a line to the points. Okay, graphing, or let's say first finding the x-intercepts. Let's just say finding the x-intercepts. Step 1, you plug 0 in for y, and step 2 is you solve for x. It's always the same. When you're finding an intercept, you always plug 0 in for the other variable. So if I'm finding the x-intercepts, I plug 0 in for y. If I'm finding the y-intercepts, I'm plugging 0 in for x. So finding the y-intercepts, step 1, plug 0 in for x. And step 2, solve for y. Now plotting points using intercepts. Step 1, find the x-intercept and plotting points. Let's try that again. Graphing lines using the intercepts. Find the x-intercept and y-intercept. Plot the points from step 1. Then step 3 is draw a line through them. Now we looked at the easiest way to graph a line, and that's to put it into your calculator. Okay, so step 1. We need to find the x-intercept and y-intercept. Now to find our x-intercept, you always plug 0 into the other variable, so I plug 0 in for y. So I got 2x plus 4 times 0 is equal to 8. 4 times 0 is 0, so it drops away. We got 2x equal to 8. divide both sides by 2, and you get x equal to 4. Which means I have a x-intercept at 4 on my x-axis. This is step 2 I'm doing at the same time, plotting the points. Now y-intercept. You always plug 0 into the other variable, so plug 0 in for x. So I got 2 times 0 plus 4y is equal to 8. 2 times 0 drops away. We got 4y is equal to 8. Divide both sides by 4. Then you get y is equal to 2. So I got a 2 on my y-axis. Now I'll put a point. Now step 3 is to draw a line through those points once you plot them. Now the beauty of the intercept method is that it's very easy to come up with those points, and then you just draw a line through them. Usually it's not necessary to get a third checkpoint because the calculation is so simple once you plug a 0 in for one of the variables. Okay, that was graph linear equations in 2 variables. Now there's another way to do that with the slope-intercept form, which we'll talk about here in a minute. That's like topic 3. Apply the slope-intercept form of a line. But let's talk about slope. And let me grab a drink here first. Your slope in general is equal to the change in y over the change in x. Now they teach you rise and run, which is I think a poor way to teach it, because it gets you thinking distance, but it's much more than that. Slope could be the change in dollars over change in time. It could be the change in alertness over change in time. It could be the change in costs over change in revenue. You can put anything in there for x's and y's, so it's much more than just rise and run. Now given 2 points where we have x sub 1, y sub 1, x sub 2, y sub 2, then your slope is going to equal to y2 minus y1 over x2 minus x1. For example, if I have 3, 5, and negative 2, 7, this is my first point, so I'll label this as x1, y1. This is my second point, so I'll label that as x2, y2. Doesn't matter which point you label as your first point, which one you label as your second point, you get the same answer either way. So then we're going to subtract our y values. So you take y2, which is 7, minus y1, which is 5, over x2, which is negative 2, minus x1, which is 3. 7 minus 5 is 2, and negative 2, negative 3 is negative 5. So our answer is m is equal to negative 2/5. Okay, slope of a line. Apply the slope-intercept form of a line. I'm guessing what that indicates there is we're wanting to find the equation line. Clear off this off. An example then. We have the m is equal to 5, slope is 5, and it passes through the point negative 1, negative 2. And the instructions say find the equation line. So, finding the equation of the line. Step 1, find m. First sub-step is to plug in the given point for x and y and m from step 1 into y equals mx plus b and solve for b. And then step 3 is to write your answer. Plug in m from step 1 and b from step 2 into y equals mx plus b. So for this problem, find m. Well, m's given. M is equal to 5. Step 2, plug in a given point for x and y from step 1 into y equals mx plus b and solve for b. So we have y is equal to mx plus b. Now we want to plug in a given point. When they give you a point, they're giving you a specific instance of x and y. So I can plug -1 in for x, and I can plug -2 in for y. So y is -2. M from step 1 we just said was 5, and x is -1. Then plus b. And then we want to solve for b. 5 times -1 is -5, plus b. Take -5 to the left side, becomes a +5. -2 plus 5 is 3, so we get b is equal to 3. Now step 3 was to write our answer down. We plug in m, which we found in step 1, which is 5. So we got y is equal to 5x, and b from step 2, which we said was 3. So we get y is equal to 5x plus 3. And that's our answer. Let's look at a little harder problem. Say I got -7, -1, and -2, and -3. Same instructions. Step 1. Find m. Well, we've already looked at a formula that gives us m given 2 points. This is my first point, so this would be x1, y1. This is my second point, so this would be x2, y2. And remember, our formula was m is equal to y2 minus y1 over x2 minus x1. So y2 we said was -3 minus y1, which is -1, over x2, which is -2, minus x1, which is -7. This becomes -3 plus 1. Negative becomes plus. And this is -2 plus 7, which ends up giving us m is equal to -2/5. Now step 2. Plug in a given point for x and y. Now you might say, well, you got 2 points. Which one do you plug in? Your choice. I'll plug in the second point. Numbers look a little smaller. As weird as it seems, both will give you the same answer. So plug in -3 for the y. M we just said was -2/5 times x, which is -2 plus b. Well, -2 times -2 is +4, so we got 4/5 plus b. Take the 4/5 to the left side, becomes a -4/5, which gives us -19/5. Now how I did that is that's a mixed number rule. So we took the -3 out in front, multiplied it times our denominator. -3 times 5 is -15, and you add number on top. -15, -4 is -19, and our denominator remains as is. Then step 3, write our answer down. Now m from step 1 we said was -2/5, so we're going to have y is equal to -2/5 x, and b we said was -19/5. So that would be our answer. Now, let me grab a drink here. And erase that. Okay. Determine slope of a line, apply the slope-intercept form of a line. We're going to apply the slope-intercept form a little bit differently here in a minute. Compute average rate of change. Average rate of change is like slope. Solve equations and inequalities graphically. Okay, we'll get back to that. Let's talk about parallel and perpendicular. If you had a problem that tells you it's passing through the point 1, 2, and it's parallel, assuming I could spell, to y is equal to 5x minus 1. And the instructions were to find the equation line, specifically a slope-intercept form. So finding the equation of the line given a point and a parallel line. Step 1, find m. First sub-step within that says to write the given line in slope-intercept form. Our second sub-step says to identify the slope. Our third sub-step says parallel lines have the same slope. So m is going to equal to, and I'll put a blank there, I'll talk more about that. Step 2, plug in the given point for x and y and m from step 1c into y equals mx plus b and solve for b. And then step 3 is to write your answer. Plug in m from step 1c and the slope, and b from step 2 into y equals mx plus b. Step 1. Find m. First substep says write the given line in slope-intercept form. Well, we're given y is equal to 5x minus 1. This is already in slope-intercept form. Slope-intercept form means you've solved for y. Our second substep says to identify the slope. Slope is going to equal to 5. If this is in slope-intercept form, then whatever number is in front of your x is your slope. And C, parallel lines have the same slope. So we said it's parallel to this line. We said the slope of that line is 5. So the slope we're looking for will be 5. These parallel lines have the same slope. So then, the steps follow the same as what we did before. Plug in a given point for x and y. So plug 2 in for y. M we just said from step 1 was 5, and x is 1, plus b, and then we want to solve for b. So 5 times 1 is 5, take the 5 over, becomes 2 minus 5. And we get b is equal to negative 3. Now step 3 is to write our answer down. So we're going to plug in m from step 1, which is 5. We'll plug in b from step 2, which is negative 3. And our answer is y is equal to 5x minus 3. Finding the equation of the line given a point and a perpendicular line. Step 1, find m. First substep says to write the given line in slope-intercept form. Solve for y. Now our second substep says to identify the slope. And our third substep says perpendicular lines have slopes that are negative reciprocals. So m is going to equal to, and I'll put some blanks and we'll talk more about that. Okay, and then step 2. Plug in the given point for x and y and m from step 1c into y equals mx plus b and solve for b. Now our third substep says to write the answer. So plug in m from step 1c and b from step 2 into y equals mx plus b. Okay, so let's take a look at an example here. We've got our point, -1, -8, and it's perpendicular to 3x plus y is equal to 7. Step 1. Find m. First substep, write the given line in slope-intercept form. So we got 3x plus y is equal to 7. Now slope-intercept form means you solve for y. In this case, to take 3x over the right side. So we got y is equal to -3x plus 7. Now our second substep says to identify the slope. The reason why we put it in slope-intercept form is so we can easily identify what our slope is. Your slope is going to be -3, whatever number's in front of your x. Now C. Perpendicular lines have slopes that are negative reciprocals. So we're going to start the slope from 1b. So start the slope from 1b, which is -3. And then we're going to write it in fraction form. Now, on this one, to create a fraction, we put it over 1. You can always create a fraction by putting it over 1. You'll find some problems already be in fraction form. Flip it. Top goes bottom, bottom goes to top. And change the sign. So it goes from a negative to a positive. So the m we're trying to find is going to be 1/3. Now it's pretty easy once you get used to it, because whatever your slope you come up with in 1b, you put it in fraction form, flip it, change the sign. You probably do that mentally. Now step 2. Plug in the given point for x and y. When they give you a point, they're giving you a specific instance of x and y, so you can use those. So y was -8. M from step 1c we said is 1/3. And x is -1 plus b. Now 1/3 times -1 is -1/3, and take that over the left side becomes a positive 1/3. And -8 times 3 is -24 plus 1 is -23 over 3. That's the mixed number rule. Take the number out in front, multiply it times your denominator, add your numerator. So -8 times 3 is -24 plus 1 is -23. And your denominator remains as is. Well, step 3. Write down your answer. Plug in m from 1c, which is 1/3, and plug in b from step 2, which is negative 23/3. And that's our answer. Grab a drink here. Okay, create linear models, create linear functions as model data, and create models using linear regression. Those two kind of go together. Now, we created linear slope-intercept form, so we created that, and that could be this construed this way to model data, because we could then take these and use them to predict what's going to happen when we change the x to 5 or 10 or 20. But specifically on those two topics, we're going to be looking at the calculator. Okay, so let's take a look at an example. Let me clear that off. Let's say I gather some data points, and I come up with these values right here. Say I come up with 7 here, 12 here, 31, and 42. And I want to come up with a linear model that approximates this. It won't be exact. Could be in some cases, but a lot of cases it's not exact. So what we're going to do is we're going to plug that in our calculator. So I'm going to exit out where I'm at. So I'll do second mode. Second mode gets you out of anything. Now press my stat button. Now I'm under the edit menu and edit's highlighted, so I simply do an enter on edit. If you have numbers here, you can press your delete over and over to clean them out. Now I'll left her over here and press delete. Okay, and x's go from 1 to 4. So I got 1, 2, 3, 4. And for my y values, I got 7, 12. So 7, 12, 31, and 42. Now I'm going to exit out. Now you first want to set your calculator up for regression. So we go into second 0. You only have to do this one time going in the catalog. We want to push this button, looks like x and negative 1. That's actually the inverse button. And it'll take us down to the D's. And we want to look for diagnostics on. If you can't get that, just keep doing down arrow. You'll eventually find diagnostics on from the A's. Press enter twice, and that sets your diagnostics on. Now, to do the linear regression, I'll do stat, right over to calc, and we want to choose number 4. It says linear regression, ax plus b. Press enter on it, press enter again. So we're going to have y is equal to ax plus b, and I get that from this first line here. So we're going to plug in our a and b we found. So a is 12.4, so I got 12.4x, and b, which we said was negative 8. And this is our linear model. Regression means coming up with an estimate. Doesn't mean it'll be perfect, but we could then use that to predict, what's going to happen when x is equal to 10. What is the y value going to be? But that's this one here. Create models using linear regression. It also covers this one right here. Create linear functions to model data. Now let's take a look at 2.6. Let me clear this off. This is transformations of functions. Now we have some basic functions. We have y is equal to x. I like to do this by example, which looks like this. We have y is equal to x squared. That's our U-shaped graph, our parabola. We have y is equal to x to the third. It's our cubic graph. Looks like this. We got y is equal to square root of x, which looks like that. Y is equal to the cube root of x, which looks like this. And y is equal to the absolute value of x, which looks like that. Okay, now let's start talking about the shifts and transformations. If I look at y is equal to x squared plus 3. When you got a number at the very end, it shifts it up or down. So on this one, the plus 3 is going to shift it up 3 because it's positive. Now that means our graph's still going to look like this U-shaped graph. We just shift the entire thing up 3 units. Which means my graph would more or less look like that. On the other hand, if you, for example, got an absolute value of x minus 2, if plus 3 shifts it up 3, then minus 2 is going to shift it down 2. Now it's still going to look like the V-shaped graph, just the entire thing is shifted down 2 units. It would look like that. Now if you have a number inside with your x, if the number's inside with your x, inside what? Inside parentheses, inside of square roots, inside of cube roots, inside of absolute value, inside of whatever, then it's going to shift left or right opposite what you think. So this minus 1 here makes me think it goes left 1, so it's really going to go right 1. Now it still looks like this is squared, so it still looks like our U-shaped graph, but the entire thing is shifted right 1 unit. So that'd be our graph right there. If I had the absolute value of x plus 5. Actually, y equals, I guess. Again, if your number's inside with the x, it shifts left or right opposite what you think. So this makes this thing goes right 5, so it's really going left 5. It still looks like the V-shaped graph. I just shifted the entire graph 5 places to the left. Which looks like that. Now if you have negatives involved, if you have a negative out in the very front, this is going to flip across the x-axis. Now remember what y is equal to x squared looks like. That's our U-shaped graph, looks like that. But on the other hand, when we got the y is equal to negative x squared, there it goes. It's going to flip it, reflect it across the x-axis. So it'll be open and down like that. That's what reflecting across the x-axis means. Now if we had y is equal to square root of negative x, instead of the negative being out in the very front, the negative is inside with the x. This is going to reflect across the y-axis. Now square root of x, if you remember, looks like this. When I say reflect across the y-axis, it's going to flip across the x-axis, or y-axis, sorry. So it'll flip to the left like that, and that would be our answer. Okay, talked about all those. Tests for symmetry. Let's talk about those. if I have y is equal to x squared. And the question is whether it's symmetric to the y-axis. Now, if I look at the graph, graphically, I can graph it. It looks like this. Now, what symmetry means is if I pick a point on the y-axis, if I come straight over to this graph, let's say the distance is 2. If I come straight over on this side to the equivalent point, that distance should be 2. That's what symmetry of the y-axis means. Symmetry to the y-axis. We're going to, step 1, plug negative x in for x, and step 2 is solve. If you can get it to look like the original problem, then it is symmetric to the y-axis. Now, symmetry to the x-axis. Step 1, plug negative x, plug negative y in for y. And step 2, solve. Now, if you can get it to look like the original problem, then it is symmetric to the x-axis. And symmetry to the origin. Step 1, plug negative x in for x and negative y in for y. And step 2 is solve. Solve it down. If you can get it to look like the original problem, then it is symmetric to the origin. Okay, for symmetry of the y-axis, I said we're going to plug negative x in for x. So we got y is equal to, plug negative x in for the x, and negative x times negative x gives us positive x squared, which looks like the original problem. So this is why it's symmetric to the y-axis. On the other hand, if I have x squared is equal, wait a minute. If I have y squared is equal to x minus 1. And I'm trying to determine if it's symmetric to the x-axis. Well, if I plug negative y in for y, so we're going to have negative y squared is equal to x minus 1. And negative y times negative y gives us a positive y squared. Now, you notice how that's equal to my original equation. That would mean that, yes, this is symmetric to the x-axis. Both these are yes. Now, the origin. If I have, like, for example, x squared plus y squared is equal to 5. And we'll plug negative x in for x, and we'll plug negative y in for y, and see if we can get the original equation. Well, negative x squared is positive x squared. Negative y to the second power is y squared equals 5, which equals our original equation. So the answer here would be yes, it's symmetric not only to the x-axis, but also the y-axis. Now it says identify the even and odd functions. And actually I got to show this by example. It clicks better if you see it by example. Okay, so we got an even function. Now I'm going to show you an example one. This is an example of an even function. If I pick the point on my y-axis, if I come straight over my graph, that distance is 2, for example. If I come straight over to this graph over here, that distance is 2. And that's true for all points on your graph, that there's a corresponding one on the other side of the y-axis, then that means it's an even function. Now that is written in terms of the y as symmetric to the y-axis. Now we have an odd function. I don't draw these too good. This is an example of an odd function. Now what identifies as an odd function is if I picked a point here, and I picked a point up here, I could draw a line through them, but if I kept going with this line, use your imagination, if this distance here is 3, then this distance will be 3. This has to be a straight line. It'll intersect here and intersect here. Now that's referred to as symmetric to the origin. Now the easiest way to identify the odd function is you start with one of your quadrants. So if I start with this quadrant, and I flip it across the y-axis, it would look something like that. Then if you flip it across the x-axis, the question is whether it lands exactly on this piece. If it does, that means it's an odd function. For your even, you start with your right side, and you flip it across the y-axis, and if it lands exactly on this side, that means it's an even function. Okay, so let's take a look. At the absolute value. The question is whether I can take the right side and flip it across and it lands exactly on this side, which it would, which means this is even. Reason why, it's symmetric to the y-axis. Now if I look at this graph, use your imagination, I won't be able to get it precise. If the question is whether it's an odd function, we have to determine if it's symmetric to the origin. So I start with one of my quadrants, first quadrant for example. Flip it across the y-axis. It would look like this, more or less. Then you flip it across the x-axis, and if it lands exactly on this part of the graph, that means it's odd. So this problem will be odd. Now we looked at the symmetry for the y-axis and symmetry of the origin by hand, algebraically. You're welcome to use those techniques if you want, but that's how you do it graphically. Okay, let me clear those off. And some of this you can watch the videos on. Piecewise functions, increasing, decreasing, min, max, operations on functions, evaluate a difference quotient. That's a little bit weird. People struggle with that, so let's talk about that. We got f of x is equal to 5x minus 2. Now our difference quotient is f of x plus h minus f of x over h. So when asking you to find a difference quotient, they want you to find this. Now our first step is to identify f of x. Well, that's easy. F of x is given. Our second step says to find f of x plus h. Well, we're going to take this x plus h and we'll put in our x in our original problem. So we've got 5 times x plus h minus 2, which gives us 5x plus 5h minus 2. And then our third step is to plug in what we found in step 1 and step 2 into this formula and somehow eliminate the h. So we got f of x plus h minus f of x over h. F of x plus h is this right here. So we're going to have 5x plus 5h minus 2 minus f of x. You want to make sure you put parentheses around the f of x, which is 5x minus 2, all over h. So that gives us 5x plus 5h minus 2. Remember, a negative out in front of your parentheses flips the sign of everything inside. So it becomes a negative 5x plus 2 over h. Now, 5x minus 5x cancels. 2 plus, or negative 2 plus 2 cancels. And we got 5h over h. And you can see the h's will just cancel here. So that gives us 5. And that would be our answer. Sometimes you have to factor out an h out of the top part. If you have 2 or more terms, you have to factor an h out before you can cancel. And compose and decompose functions. Let me talk about that. We've got f of x is equal to 3x minus 1, and g of x is equal to 5x plus 2. Now this is the composition symbol. This is saying to find the composition of f and g. Well, this is the same as finding f of g. Some students in the past think, well, this composition symbol, can you just think it as of, over of? So it says f of g. Yeah, and that's a pretty good way to think of it, actually. Now, if you were to cover up this g, we're finding f of something. So we're evaluating a function. So we're going to go to our f of x, which is 3x minus 1. And where our x was, we put in a parentheses. Now, evaluating is always the same. Whatever's inside the parentheses right here is automatically what you're going to put in down here. But g is equal to 5x plus 2. So this becomes 3 times 5x plus 2 minus 1. So 3 times 5 is 15x, 3 times 2 is 6, minus 1, which gives us 15x plus 5. Now you can also find the composition going the other direction. Find the composition of g and f, which is g of f. So we're going to go to our g of x, which is 5x plus 2. Wherever I have an x, I put in a set of parentheses. Now evaluating is always the same. Whatever's inside the parentheses here is automatically what we'll put in right here. But f is equal to 3x minus 1. So this becomes 5 times 3x minus 1 plus 2. 5 times 3x is 15x. 5 times negative 1 is negative 5 plus 2, which gives us 15x minus 3. And that's our last topic, compose and decompose functions. Now I'm going to go ahead and save that, and then I'll answer any questions you have.